Good morning. Today we are doing course objective 24. I can interpret and create box and whisker plots. So we're continuing our work on data. We did the mean, median, and mode with the range. We did line and bar graphs. Now we're doing something that's a little bit trickier. So we really need to pay attention. We're going to be doing box and whisker plots. And in that, we're learning about the interquartile range and what all of that means. So first thing we have to do is understand all of this new vocabulary. So a box and whisker plot is a data display that divides a data set into 4 parts using the lower extreme, the lower quartile, the median, the upper quartile, and the upper extreme. And we're going to go through what all of those mean. The lower quartile is the median of the lower half of a data set. So if we have, I'm just going to do this. So if we have, let's just say that's our data set. We're going to look at the median of the data set would be the 5. That's right in the middle. Median means middle. So our middle is the middle of all of our data. So now the lower quartile is the median of the lower half. So we're going to look at the bottom half of our data set, and we're going to find the median of those numbers. So our median here, we've got 1, 2, 3, 4 numbers. In the middle of it is the 2 and the 3. In between a 2 and a 3 is 2.5. So that's the median of the lower quartile. So that is our lower quartile. The median of the lower half. So the upper quartile is going to be the median of the upper half. So we've got 2 numbers in the middle. In between 7 and 8 is 7.5. So the upper quartile is the median of the upper half. The lower quartile is the median of the lower half. Our lower extreme is the lowest number of our data set. So that's the lower extreme. Our upper extreme is the greatest value of the data set. So to find the interquartile range, you find the difference between the upper and the lower quartiles. So if it's interquartile range, you do the quartiles. So 7.5 minus 2.5, which gives us 5. So 5 would be the interquartile range because you're going from the upper and the lower quartiles. If they want the range of the whole data set, that's when you go from your upper extreme to your lower extreme. That's the whole entire data set. Now we're going to get into what the box and the whiskers look like and how we read those using these terms. So in the Khan Academy that some of us have looked at, we've seen the box and the whiskers, and we've seen the median line. We're going to start to understand where these terms fit in on those graphs. So the box and whisker plot displays data beneath a number line that represents the range of data. The median separates the upper half of the data from the lower half. So again, we're going to see what all of these new vocab words look like as we actually use them. So making a box and whisker plot. Let's say the heights in feet of 10 suspended roller coasters in the USA are 35, 42, 42 and a half, 60, 60, 70, 76, 78, 81, and 100. So we're going to make a box and whisker plot of this data. So the first thing I'm going to do is I'm going to write all of these numbers so they are in one line. So I can easily find the median. We know how to find the median. We have worked on that. 100. So those are my numbers. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my median has 5 numbers on one side and 5 numbers on the other side. So what number is that going to be? If I have 60 and I have a 70, what is my median? Brielle? 65, because that's the number that comes right in the middle of 60 and 70. So my median is 65. So now I need to find my upper quartile and my lower quartile. So I know I'm separated right here. Remember that upper quartile is the median of the upper half. So I have 70, 76, 78, 81, 100. What is my upper quartile? Well,
78.
78, because that's the one right in the middle. What's my lower quartile, Aiden?
42.5.
42.5, because that is the middle of the lower half. Now I need to find my extremes. What is the upper extreme? Nolan?
100.
100. What is my lower extreme, Landon? 35. So looking at the data, now we know where each of those vocab words fall in it. So now it says plot the 5 values below a number line. So we're going to look at, and actually I think on Khan Academy they actually plot it above the number line. So we're going to make a number line. And that's 65. So let's see. We've got 35. We've got, I'm just going to draw them right by each other like this. There's actually 2 60s. So on Khan Academy, you'll see them put dots for the numbers like that. One dot for each value. So you'll see something like that on Khan Academy, where they will put dots above the numbers so you can see how many of each number there are. Now we're going to do some plotting. So draw a box connecting the quartiles. So we know that 42.5 was one quartile, and our other quartile was 78. So that is each end of my box. We've got the lower quartile is one end of the box. The upper quartile is the other end of the box. So those are our 2 quartiles, the 2 medians of the upper half and the lower half. Then we have our median of the whole thing. So you'll see a line in the middle of the box. That's the median of all of your data numbers. The median of your data set is that line that goes through, let's do it in red. That line that goes through the middle is the median of all the numbers. Then we have our extremes. Those are the whiskers. So we've got our box, goes from the lower quartile to the upper quartile with the line for the median. Then we have our whiskers. The whiskers go from the lower extreme to the upper extreme. So we know our data set goes from 35 to 100. And I didn't write my numbers out for these. So this was 70, 76, 78, 81, 100. So we know that our data range of all the numbers goes from 35 all the way out to 100. So the whiskers show the extremes, the lowest and the highest. So our box shows the lower quartile to the upper quartile with the median of all the numbers in the middle. Is that making sense?
Yeah.
It helps when we have the vocab words with the pictures going together. So now it says interpreting a box and whisker plot. A box and whisker plot helps to show how varied or spread out the data are. Using the above roller coaster example, suppose all of the roller coasters in Minnesota are suspended under 42.5 feet. About what fraction of the roller coasters are in Minnesota? So if they are suspended below 42.5, what fraction of all of our data set would that be? What do you think, Nick?
The lower, I can't remember.
Yeah, this is something different from what we did on Khan Academy.
Honestly.
Yeah. So this is drawing conclusions. On Khan Academy, they don't have you draw conclusions about the data. Khan Academy is just about being able to read the box and whisker plots. Now we're doing that extra step of drawing conclusions. What is this telling us? So if they want a fraction, how many data are there all together? 10. So that's going to be our denominator because it's out of 10 roller coasters. It says what fraction of the roller coasters are in Minnesota? If Minnesota is all below 42.5, how many are below 42.5, Tristan?
3.
Below 42.5. There's only 2 that are below. We can't count the 42.5 because we want below. So there are 2 roller coasters out of the 10. So 2/10, or we could simplify that and divide out that 2. So it's 1/5 of the roller coasters are located in Minnesota. Because we were able to see that only 2 of them out of the 10 fit what we were looking at. So when they're asking for the fraction, that numerator is the part that fits in, and the denominator is the whole. How many all together? So the denominator is the whole. How many we have all together? The numerator is the part. How many are actually working out of it? So our part was the 2. Our whole was how many altogether? There were 10. Does that make sense? Our second question says, suppose all of the roller coasters suspended from 42.5 to 78 feet are located in Wisconsin. About what fraction of the roller coasters are located in Wisconsin? So thinking about what we know about our part and our whole, what fraction are located in Wisconsin? Will?
4/10.
So Will is thinking 4/10. So we got the 10 because there are 10 roller coasters altogether. But what is the part? We're looking at between 42.5 all the way to 78. How many roller coasters are there between 42.5, starting at 42.5 and going up to 78? So it says from, so it doesn't say it can't be 42.5. It says from 42.5. So you were close, you were on the right track. But it's saying from 42.5 all the way to 78. So we're going to count the 42.5 and the 78. So it would be 1, 2, 3, 4, 5, 6. So I understand where you got the 4 from. But we have to be careful when we're reading these. If it says under, we don't include that top number. But if it says from this number to this number, we do include them. So it would be 6/10. What would that be simplified? What can I divide out of the 6 and the 10? Maya?
2.
I can divide that 2 out. So 6 divided by 2 is 3. 10 divided by 2 is 5. So 3/5 of the roller coasters are in Wisconsin. So if we know 1/5 is in Minnesota and 3/5 is in Wisconsin, we can figure out what fraction is not in Minnesota or Wisconsin. Tristan?
1/5.
1/5. Because 1/5 plus 3/5 is 4/5. And then the rest of it is outside of Minnesota and Wisconsin. So if I have 4/5 in Minnesota and Wisconsin, 1/5 is outside of Minnesota and Wisconsin. Is that making sense?
Yes.
So we're gonna go through the workbook page. We're gonna go through the first example on it, the first problem, to see how we are doing with our understanding of these box plots. So for my friends at home, I'm going to switch over to, let me see how easy this is. If I can switch this over for the recording. And I'm not sure I can switch the camera. So I'm going to stop there for my friends at home. And I will do another recording. Because otherwise it's just going to stay on the screen. I'm going to see if I can do a recording. All right. So we are going to stop here and say goodbye.